Thank you, Bob. Thanks for getting everything worked out so that everybody could be on. I just want to welcome everybody to the second session of the 2021 virtual P2 and just, express my thanks to all who are going to be talking today and giving us updates from the EPA, because I certainly do appreciate everybody's time to do this. It's one of those things that we all look forward to, just from the perspective of hearing what's going on inside the agency, and especially since this is a transition year from one president to another. So it'll be interesting to hear these updates and get the perspectives. So that's from me. I just want to welcome everybody. And again, I'm Judy Morgan. I'm the current chair, and I'm with Pace Analytical. And then Brad Meadows, did you want to just give a little introduction of yourself?
Sure. Thanks, Judy. This is Brad Meadows. I'm the vice chair of the group. I'm the vice president and technical director out here at Babcock Laboratories in Riverside, California. So welcome, everybody.
Thanks, Brad. David, I'm going to turn it over to you so that we can get on with our agenda. So thank you so much.
Okay, our first presentation is going to be about the Safe Drinking Water Act Methods Program. And we're happy to have Dan Hauptman, who's the Deputy Director of the EPA Office of Drinking Water and Groundwater's Technical Support Center out in Cincinnati, Ohio, talking to us today. For those of you who are not familiar, the center out in Cincinnati is responsible for the analytical methodology that's used to support the drinking water program, and also for the UCMR program and the drinking water laboratory accreditation program. That's the only EPA program that has a formal laboratory accreditation program, as you know. We have appreciated Dan's involvement with us with ACIL over the years. He's been very helpful in keeping us up to speed and working with us, and we really appreciate his help. And we're glad that Dan is willing to come today and talk to us. We'll continue to keep us in the loop as to what's going on in the program now and hopefully in the near future. I'll turn it over to Dan. Thank you.
Thanks, David. Keeping all of you in the loop requires me to maintain being in the loop with everything that's going on at headquarters. Since we are a satellite office, I'm located actually in Cincinnati, Ohio, and I keep a pretty close ear and stay abreast to the various activities that are happening. But there's a lot going on continually, and particularly when you're talking about a subject that I refer to as the 800,000-pound gorilla, that being PFAS. It's not just the 800-pound gorilla. I've often referred to it as the time-sucking vortex, because there isn't a day that goes by before 9 in the morning where I'm involved in a conference call or a meeting or an email discussion or something related to this complex issue that we affectionately simply refer to as PFAS. But David took away my introductory thunder in terms of explaining what we do out here in Cincinnati. And you covered 3 of our primary programs that we support, namely method development, validation, review, and approval. The second being the Lab Cert national oversight of the Lab Certification Program, working with our regions who interface directly with our states, who interface directly with you, the laboratories. And also the UCMR rule activity, both the development of that regulatory action through the notice and comment proposal and final proposal, receiving comments, and then issuing the regulatory action specific to that 5-year cyclic program. But the fourth topic that you didn't cover, which really doesn't affect any of you laboratories, is our optimization team. These are the engineers within our group that provide a lot of technical support and training, working with typically smaller utilities in certain states that are partnered with us, and in regions that have established an optimization program, working with them to optimize their treatment performance such that they can clearly stay within compliance limits, most often for things like disinfection byproducts. But they've expanded their role to cover like treatment for toxins and other priority areas. So there's a lot of engineers in our group. Well, there's 4 that work on that program and provide a lot of great support. But I'm not here to talk about engineering support or UCMR per se, although I will touch on that, but talk about recent activities involving methods and monitoring work within the Technical Support Center. The unfortunate outcome of the pandemic was the cancellation of your meeting last year. So I was prepared to present the new publication of the 533 method for PFAS, which came out in December of 2019. But I'll mention it now in case you hadn't heard. This is, and many of you I know are aware of this. And before I go further, I want to thank all of you who were involved in the validation process for that method. 2 years ago, when I addressed your committee meeting here, I put out a plea to please respond favorably. And there is a profound amount of interest in PFAS monitoring. And we had more labs volunteer to participate and help us with that validation than we have ever had on any other validation request. So I do want to express my appreciation for that. And Steve Wendelken would also relay the same message. Anyway, for those who don't know about 533, it is a method we developed focusing in on what we call short chain PFAS. Now, short chain is kind of a arbitrary term in general. Bottom line is it focuses on carbon chain lengths in the 4 to 12 types of range. A total of 25 PFAS are included in the method. It's really designed to complement the EPA method 537.1, which was published in November of 2018 and covers 18 PFAS. So there are 11 additional PFAS within the 533 method. One important distinction that is associated with the 533 method, we've heard the laboratory community who for years have argued about having isotope dilution represented in a method that focuses in on these priority PFAS contaminants. And so we do have that particular protocol established for quantitation within that method. And quite frankly, I think it's been working fabulous. I mean, there's been a lot of work monitoring of even non-drinking water matrices, dare I say it, that have picked up the method, and with the isotope dilution have been able to get really accurate and precise results for source water type samples that generally aren't something we encourage laboratories to just blindly do with a drinking water method. But I think the isotope dilution gives you a lot of functionality and flexibility to be able to expand it. Other methods that are currently in development, we drafted a method called that we've assigned the number 558. This is a solid phase extraction GCMS type method for the determination of urethane, also known as ethyl carbamate, and N-methyl 2-pyrrolidone. It's specific to finished drinking water. These are two priority CCL contaminants that have been on the list for, I think, a couple cycles. We've put out a draft method and we're in the middle of a validation program. We didn't get as widespread of interest in participating on that one, but for those labs out there that have contacted us, again, we appreciate your involvement. Additionally, we're looking at methods for polar pesticides, endothol, glyphosate, other CCL priorities. One thing we're critically looking at is ways to apply the LCMSMS technology beyond our UCMR methods and PFAS and acid amylate degradants. We've been utilizing LCMSMS technology in methods for UCMR going back to, I think, UCMR 2 was the first cycle where we picked it up. But we haven't heard a lot of interest until recently about, what about picking up some of these other compliance parameters with this technology? It's fabulously sensitive, wonderfully selective, It works really great. So we've told it was a state lab that presented this to us. Submit the method that you've worked on, and we've actually reviewed it and are going to be coming out with an expedited action that will identify it. I won't get into too many details because we haven't yet published that next expedited action, and there are elements that I really have to wait for that to come out before I talk about. Anyway, my point though is that LCMS-MS is definitely here to stay, and we continually want to hear about others who have approaches that might be appropriate, particularly to complement older methods that perhaps aren't as friendly to monitor for some of the compliance parameters. So I'll leave it at that. And again, a critical note: we're always interested in working with laboratories that have questions, concerns, issues, and willing to offer assistance with the validation process that we go through whenever we come out with a new procedure. I also want to mention a work that has gone on with respect to EPA radiochemical methods. The revision to 900.0 came out a couple years ago, and we have expedited that for approval. What we've done is include some clarifying language within these methods and specified specific QC frames. Several years, I'm thinking about 5 years ago, we had some direct engagement and discussion with some critical stakeholders that were concerned about the variable degree of data, how the data that they would receive for radiochemical monitoring from two different labs could be so disparate, so different in terms of what they were receiving as a result. And a lot of it came down to the way the individual labs were processing and evaluating the sample. And so what we strove to do and were encouraged to do was to include some clarifying language about processing and some factors about QC that could hopefully normalize some of the differences we were seeing in the radiochemical data to support the drinking water compliance work. So 900 has been completed and has been approved. 903.0 and 903.1 have been published as revisions, and in the next expedited action, which is weeks to maybe a month away from being published, they will be identified for approval. Can't say they're going to be approved because that hasn't actually happened yet, but all things are pointing that direction, and the wheels are turning, although slowly. I do work for the government. EPA 904 is another RAD method that we're in the process of updating, revising. Hopefully we'll have that completed later this calendar year. I've touched on the expedited method approval action that is forthcoming in the near term. It will not be months away. It will be weeks, maybe a month. It depends upon timing relative to when we can get our office director to sign off on it. Our office director, Jennifer McLean, has been delegated the authority to sign off on all of our expedited method approval actions. These are published as FRNs, and by virtue of taking that approach, we're able to include those methods within Appendix A to Subpart C in 40 CFR 141 as optional additional methods that have been approved for compliance. Let me talk a little bit about UCMR activities. Our UCMR, as you probably all realize, UCMR is the program that turns like a wheel, and we are just completing UCMR 4. We are in the 5th year of the 5-year cycle. The monitoring period was supposed to be completed in December of 2020, but we always build in 1 year at the back end of the 5-year cycle to, quite frankly, mop up and do follow up for compliance and leave our data reporting system open for the entire time to let samples continue to be reported, often as makeup. Sometimes they just completely forgot to do the monitoring, and they have been informed by, typically the regional enforcement office, that this is a statutory requirement that has been defined in the regulation. So it's not like it's an option. Sometimes we run across systems that have this opinion that this is just like an optional program that we have to do, right? It isn't really something that we're obligated. No, it's a requirement. Anyway, on to the next cycle, UCMR 5. Most of you are probably aware on March 11th, we published our proposed UCMR 5 rule. We had the privilege of being signed twice as a proposal. We were signed in the waning days of the last administration, and the pre-publication of that was released. Then it was decided that all of those actions would be subject to subsequent review, and we didn't make it to the finish line with an FRN, a publication of that signed proposed rule. So we had to go through some review and discussion and briefings, and it was determined that let's go forward with what we have, and it was re-signed by our current, our then acting administrator, and that has been published earlier this month. There is going to be a couple stakeholder webinars that are scheduled for April 6th and the 7th. These are replicate meetings. There's no difference between the two of them. We just realized that if you're on the West Coast versus the East Coast, the timing can be a factor. And we also realized that we may have a large array of attendance. And so making it a little more efficient to divide up the attendance. We encourage people not to register for both. I don't think you actually can. But if you go out online to look under, do a Google search for UCMR 5 meetings and materials, and you'll see the links to register for that particular webinar. One of them on either of those days. We are in the middle of the open comment period right now, which will go for 60 days. So I think it's May the 10th is the end of the 60-day period. We've proposed monitoring for 29 PFAS with the two PFAS methods, 533 for 25 of them, and then for 4 additional longer chain ones that are part of 537.1. Those are the proposed methods that we've got identified. And we also have lithium by 200.9 as an additional proposed target. I'll say hope, maybe anticipate would be a better word. The final rule would come out later this calendar year. I won't be shocked if it extends into the beginning of 2022. I only say that knowing how long it takes. It's typically about a year to address comments and get everything packaged and put together as a final action. And what's interesting is this is a situation where we have to sleep in the bed we make, where we are direct implementers of the UCMR regulation. And so what we have proposed is that for monitoring to start in January of 2023. Well, any state that you talk to would clearly indicate implementation is a lot of work, and there's a lot that you have to do to be prepared to put an implementation program together. EPA has to do that, and we do that in this 1 year between having a final rule, ideally 1 year, and the start of monitoring. So in a perfect world, we'd have a final rule out in December of this year, January of 22, and we would start monitoring in January of 23. And it would allow us time to have everything related to lab approval put in place, everything related to our reporting system ready to go, everything related to actively doing a direct implementation put in line so that it can flow off without I'll say significant hurdles. There's always hurdles that you have to overcome. It's inevitable. One of the provisions that are specified, and I've talked about this in the past, something that Congress passed that we refer to as AWIA, the America Water Infrastructure Act of 2018. It requires us to directly sample from all small systems that serve between 3,300 and 10,000 individuals. And the way the statute is established for UCMR monitoring, EPA pays and coordinates all of that sample collection effort. This is going to expand our small systems from about 800 to closer to 6,000. So a 7.5-fold or so increase, let's call it 8, 8-fold increase in the number of systems that we'll have to coordinate and pay to have this sampling and monitoring occur. That's going to be a pretty significant effort for our office, and we're going to have to rely on commercial lab support, establishing contracts with various entities. And that's where I want people to be aware that opportunity is knocking right now. What you need to do as a commercial lab is you need to be aware that you need to first register with the UCMR laboratory approval coordinator. And if you go online and just simply do UCMR 5 lab approval, you will see the various links and the steps identified as to what you need to consider and do. And so in order to serve as one of our awarded contract labs, you will need approval in all the methods to do the monitoring for all of the contaminants that we have in the final rule. We don't parse out and divide up kits to send some samples to one lab and another to a separate lab. That would be far too complex when you're talking about a monitoring program that is this type of scale. So that's the really bottom line, is that if you do want to get involved, let us know and register, and we'll take it from there. You'll get the application material and begin to work on that. It is in your best interest to get that in place as early as you can, because I am going to encourage our contracts office to make a prerequisite for consideration of award, not only award but responding to the proposal, that the laboratories have the requisite EPA approval to support the program for all the methods relative to all the contaminants. So that's all I really planned on covering. And I don't know, Dave, do you want to handle questions now or at the end?
Yeah, why don't we handle questions now? I've got one, Dan. What is the approval process going to be for in case anybody doesn't know, for the laboratory to participate in the UCMR 5? Can they have to have, like, for example, NELAC accreditation for all the methods, or what's the
good question? It's a good question. What we have as a principal prerequisite is the laboratory has to have drinking water certification in a method that parallels one of the methods in some degree that we are approving for monitoring. Now, granted, we don't have LC-MS methods that we have available, and I don't know off the top of my head. I think it might be 525.2. If you have certification in that type of drinking water method, then you have to include that in your application, and that at least sets the stage for you going to the next steps. So that's an important thing to recognize, because I know we've already received one inquiry from a laboratory that has no accreditation, no certification, doesn't do drinking water work, but they really want to get into this PFAS arena. And it's like, no, you can't go to that point without having that baseline drinking water qualifying certification accreditation.
Okay, thank you. Any other questions, Dan?
Let me just give you the brief 10,000 feet. In addition to having those prerequisites, you complete the application. The application requires the lab to record performance data, basically initial performance data, along with, MDL, MRL calculations and that data to support it, basically demonstrating that you can actually hit in the case of the PFAS, the primarily single-digit part per trillion MRLs that we have proposed as part of the action. Once that application comes in and there are no questions or open issues about it, that will qualify the lab to be what we call PT ready. And so we will send the lab a PT that they will have to analyze and report the data back to us. And then if they pass that PT, then they will receive approval once we have a final rule. If they do all that before we have a final rule out, they will get a pending approval notification, because we can't approve them for something until we have a final regulatory action that describes what they're going to be approved for. It's a little bit of semantics, but that's a 10,000-foot review of what's involved with lab approval.
Thank you. Other questions for Dan?
I've got one. So I'm just kind of curious, are you expecting a lot more laboratories to come into the program this year?
Judy, that's a good question. I don't know. If I could predict the future, I'd probably win the lottery. I think that the amount of labs that have gone to their banker and gotten loans to buy a $400,000 or so piece of equipment, an LCM SMS, I think that has increased significantly back from UCMR2 when I think it was 535 was the method. I think that goes back the history, right? But I do think there's a lot of labs that are going to be able to demonstrate that they have the capability and will be able to meet the requirements. One thing also I'll throw in, we logically looked at the way we've done PT passing in the past. When let me just say, for instance, UCMR3, where we did 6 PFAS, the labs had to pass all 6 in one PT swing at the plate in order to be considered approved for that method to do reporting for all 6 PFAS. We're not going to have that as a expectation for method 533, where we have 25 PFAS included. I mean, the likelihood of a lab never having an issue with 1 or 2 of the 25, the reality is this could end up putting labs in a position where they're constantly trying to chase and get a perfect score. So we're going to be looking at applying a logic where you have to at least pass the 1 PT per an analyte for that method, because there are so many analytes within that method as we have proposed within the rule.
Sort of like the approach that Clean Water Act and the RECRA programs have taken, and NELAC is working on. So
I don't think there's any method in drinking water compliance that has 25 parameters that are regulated. I'm almost certain that that doesn't exist.
What's your gut feeling as far as, given you're expanding this to so many other small drinking water systems, is the plan to have a few large contracts or to have a lot of small contracts with labs for the UCMR?
Yes and yes. I mean, we tried to consider how many. Right now, we've been running under UCMR 4 with 3 contract labs. We're going to need more than 3. I mean, one of those labs, I actually had a frank conversation with at one point, and I wanted to know if they were in a position to receive more sample. They were getting, I think, about a 30% slice of the total sample load at that time. And I kind of wanted to get a feel for what really their capacity was, because they're a smaller business lab. And they were like, oh, we're good. We love all the work you're sending us, but yeah, it's keeping us real freaking busy. And, they were happy with where they were and didn't really want to stress their system to that extent. And, under this model for this next cycle, I'm guessing we're going to have at least 6, if not maybe as many as 10 contract labs working for us. And for those of you who don't know, the way we've modeled this in the past is the laboratories that are working under contract, they do not produce the kits that get shipped out. We have a separate contractor. We have had a company, Great Lakes Environmental Center, coordinate the sample collection, the distribution of the kits, the follow-up when a kit doesn't come back from that utility. So we have to hear from the labs to make sure, did you or did you not get a kit this particular week? The system was supposed to collect. And believe it or not everybody does what they're supposed to do when they're supposed to do it. And that's an action that the labs don't have to bear upon themselves, other than letting us know what they get, so that we can have our coordinator contractor take care of all that. So anyway, that's just one factor that you should be aware of.
Thank you. Other questions, comments for Dan? Okay.
I will throw one other thing in, just based upon a bird whispered in my ear, and so I know there was concern about some of the parameters and methods that we identified in early stakeholder meetings that we were considering for the next cycle, and those have not been proposed, and there is rationale included in our proposed rule as to why we took that path. These are all things certainly that people can comment on. Stakeholders can comment on, but the factors that pushed us to excluding them are real, and cost was a significant contribution. I mean, the after the fact comments that we heard from a lot of utility stakeholders complying with UCMR4 in terms of the number of methods that were involved and the amount of cost that attributed to it was I'll just say deafening. I mean, there were a lot of utilities that really we worked with them so that they could do things somewhat creatively in order to comply with the monitoring requirements, because quite frankly, we need the data. So if they need to spread their sampling out a little bit beyond a single year, we kind of looked into ways for them to comply with that as an allowance to spread their cost out. But the early meeting we always have, we throw everything out there that we're considering, just so people are aware that we're not forgetting stuff. But when it comes to putting the proposal out, we really have to look at numerous factors in terms of what we identify. But again, that's why it is a notice and comment, and we have a 60-day open period for stakeholders to express opinions and allow us to respond or adjust.
Thank you. I'm going to throw one thing on the table, Dan, for you and all our other speakers from EPA. Given how short-handed all the methods programs at EPA have been over this last several years, is there any move to get you guys more resources to fill in your staffs, get more help?
Yeah, from the drinking water side, I have heard some favorable high-level discussions that may translate into us being able to expand. But again, it's always something for whatever program you're in that you have to be able to justify. And one clear justification we have isn't so much rooted in method development work as much as it is being able to pull this whole UCMR5 program with such a profound expansion of the small systems. A lot of our staff are directly involved with coordination of the small system work. And if that volume of work is increasing by a factor of 7, now we're not going to see a 7-fold increase in our staffing. But if we could have, I'll say several additional staff pulled in to assist, those staff will be able to support other aspects of our program when they're not directly involved in UCMR work. And some of that could be related to methods.
Yeah, well, I wasn't thinking just methods. I just know that like technical support activities and other things have been, it's difficult with the short staffing. So hopefully that'll turn around.
Yep.
Okay. Thank you very much, Dan. We'll switch now to the Clean Water Act program. and we're happy to have Brian D'Amico, who's the chief of the Technology and Analytical Support Branch within the Office of Office of Science and Technology's Engineering and Analysis Division. They're the ones who are responsible for the methods development and approval for all testing methods used in implementing the Clean Water Act. Also joining us today will be other members of Brian's team, including Adrian Hanley, I see is here, who heads up he's a senior chemist and team leader of the methods group. And I don't know who else from the program, and Lem Walker, who leads the alternative methods program activities. So we've got at least the key people, a lot of the key people from the Clean Water Act methods program. Let me now turn it over to Brian and his team. Thank you for coming.
This is Brian. I will just quickly introduce sort of who we are, and then I will turn it over to Adrian to talk about a little bit of what we've been doing. But in general, we are the Clean Water Act Analytical Methods Program. I'm sure most of you know this, but a number of industries and municipalities have NPDES permits that allows them to discharge pollutants to waters of the U.S. They use analytical methods to analyze those discharges, in particular the chemical, physical, and biological components, to document compliance with the limits in their permits. The Clean Water Act requires EPA through rulemaking to establish test procedures to measure pollutants for Clean Water Act programs to use, and we promulgate these test procedures in 40 CFR Part 136, and those methods are approved for national use in things like NPDES permits once it's been promulgated. Speaking directly to the last question about staffing, I am the branch chief. I've been in this position for about 4 years, and when I came on board, the methods program was a team of 2, Adrian and Lem. We've grown a bit since then over the last 4 years. Adrian, a chemist on the team, is still the team lead. Lem Walker, another chemist on the team, is still the national ATP coordinator. We also have Becca Burkett. She started a little less than a year ago. She's another chemist on the team. We have Tracy Bone. She's our lead microbiologist. We have Megan Hessenauer. She's another biologist on staff who runs the whole effluent toxicity program for the team. And finally, we have Morgan Tichy, who is another microbiologist on the team. So we've grown a bit over the last couple of years, and I am optimistic that we'll continue to grow. I mean, nothing concrete, but I think we're more than able to demonstrate that the workload on our plates far exceeds even this expanded staff. So that's who we are, and I'll turn it over to Adrian just to quickly talk about what we've been working on over the last year or so. And thank you for having me here.
Thanks, Brian. So everyone, that was our supervisor, Brian, for the Clean Water Act Methods team.
Okay.
Presentation mode. These were Brian's slides, which he did a fantastic job of without the actual visual. And more interesting for those that want to know the spelling of our various team members' names, here's slide 3, which basically has everyone on the Clean Water Act Methods team. We're chemistry heavy because most of our methods are chemistry methods, and then we have 2 microbiologists and a biologist. The other thing I want to talk about is, as Brian mentioned, in order for a method to become quote unquote approved for NPDES permits, they have to go through rulemaking. Over the last few years, after a lean activity, we decided that we needed to, instead of doing a methods update rule every 5 or 7 years, that we probably should do smaller method update rules. The main thing which held up our normal method update rules were usually 1 or 2 controversial items. So our idea moving forwards was that we would do a routine methods update rule every 1 to 3 years. Our idea is that once one finished, we'd start the next one, assuming we had enough content, and that these routine method update rules would basically have what we judge to be non-controversial items. And generally speaking, these are ATPs, because alternate test procedures are for analytes that already are regulated. There is a big misconception out there that you can do an ATP for anything, but that's not the case. Any sort of minor editorial updates or revisions to our methods that we considered to be, very minor, and also other non-controversial items, mainly like updating BCSB approved methods. Often it's just, the new year of the method that voluntary consensus standard body approved. And on top of that, there's sometimes some minor changes, but each of the voluntary consensus standard bodies that do update their methods and submit them to us provide us a red line strikeout so we can see, exactly what's changed from the currently approved version of their method in 40 CFR 136 to the new version that they'd like to have approved. And then less often, of course, we will still continue to do non-routine method update rules, which contain things like new methods, or, for instance, in the last MER, when we revised the 600 series methods, that was far more controversial than we thought it was, just because so many labs run them. And then also, of course, revising the method detection limit, we knew that would be controversial. That wasn't much of a surprise. But, content like that, new methods, new analytes, new regulated analytes would all be lumped into non-routine method update rules. We proposed a routine methods update rule in 2019. As I said, this had all stuff that we thought was pretty non-controversial. BCSB updates, a couple HEPs, minor clarifications and corrections. We only received 25 sets of comments, which is really small compared to a normal methods update rule. I didn't think any of the comments were particular showstoppers. We really expect this rule to go final and get posted with a response to comments sometime in the reasonably near future. Honestly, we thought it was going to get finalized last year, but whenever you have an administration change, things just get slowed down a little bit, especially on the regulatory side. On the microbiology side, we are working on a rapid method for E. coli and enterococci by droplet digital PCR for ambient water. This validation has been moved along. It's a single lab validation, but we did use 2 different laboratories where all the lab data has been finished and it's currently being reviewed. And I would anticipate report writing and method writing, or draft method writing, because it's only a single lab, will be happening in the next few months. The main reason for this method is mainly that we wanted to shorten the response time for swimming advisories. And currently all the approved E. coli and enterococci methods are culture methods, which take days, whereas this method would take hours. My pet project is our PCB congener multi-lab validation method. I think you guys have been hearing me talk about this for at least 5 years and are probably tired of hearing about it. I can tell you that it's near completion. We had 7 laboratories complete the multi-lab study. We mainly are a wastewater shop. That our methods that get approved are for these permits and wastewater. But we did also test several matrices for biosolids, sediments, and fish tissue, because usually whenever you have a Clean Water Act contamination, you are often interested in those matrices also. So this method, I like to say, it took the Goldilocks path forward. There are 209 PCB congeners out there. We thought calibrating 209 congeners would be somewhat excessive, so we kind of took a middle route. We basically fully calibrate 48 of the 209 congeners and then indirectly quantify them with all 209 congeners with those 48. We have 29 isotope dilution standards and 3 post-extraction isotope standards for this method. I think the QC is extremely robust. We've already finished the report and the method. It's going through review as we speak, both through an EPA work group, and we had some people outside of EPA and some of the laboratories, commercial labs that participated in the multi-lab validation, basically do a full review of the report and the method. I can't really say when this will see the light of day and go on our website as an unapproved method, because that decision happens a little higher than my pay grade. But I really hope that we'll have this on our website sometime in the next few months. With that being said, that is a hope. That is not what may actually happen. Another of our big projects is gross alpha beta method 900.0 revision. EPA's Office of Groundwater and Drinking Water already approved a revision of 900.0 in 2018 during one of their expedited rulemakings. So it seemed that we should probably follow suit and try and harmonize with OGWDW's efforts, and also update 900.0 for the Clean Water Act rather than use the current version that's in our reg that is from 1980. We plan on leveraging as much work from OGWDW as possible and harmonize the method as best we can. Right now, the study plan is under review, and I think that we'll probably start doing some lab testing later this year. I would like to clarify that this is a revision. This is not a full-on multi-lab validation. 900.0 is it's already an approved method. Our main goal here is to really just update it and make it look and smell like a method that a laboratory runs today. Another project that we're very excited about is adsorbable organic fluorine. We all know that there are thousands of man-made PFAS compounds out there, but what really caught our attention is that as we started looking into organic fluorine compounds, there aren't a lot of naturally occurring organofluorine compounds that are known to exist in nature. I looked around for a long time and literally found one reference in the 2002 version of the Handbook of Environmental Chemistry that mentioned, they may exist as a byproduct of volcanic processes. So this really was interesting to us because if almost all the organic fluorine out there is man-made, then it makes it an interesting parameter to look at for wastewater, and just sort of potentially use as a screening method for all kinds of things. I mean, mainly PFAS, of course, but the other organic fluorine compounds that come to mind are some pesticides and some pharmaceutical projects also. But we haven't found any references to any naturally occurring organic fluorine products, which is why this was such an interesting project to us. We looked around at what was out there, and the closest thing to a method was a draft ASTM standard that is currently in development. So we reached out to ASTM, and currently we are collaborating with ASTM on a single laboratory validation of their draft standard. So basically our plan is to basically pay the bill, share all our data with ASTM, and hopefully get something over the finish line that both ASTM and EPA can use. Now that would be quite a ways from now, because as I said, at the moment we're just writing the study plan for the single lab validation. But we're really hoping that this works out, because I think it would be a fantastic tool, especially for a contaminant like PFAS, where there are just so many unknown and known non-monitored compounds out there. And of course, I forgot to mention, it is a combustion ion chromatograph method, and it looks promising. It may not be the most sensitive method in the world, but we think it has a really good screening application. One of our other main projects we're working on right now is PFAS method validation with the Department of Defense. I'm going to not talk a whole lot about this because I see Jordan Adelson is later on the agenda, and I imagine he will get much more into depth than I will. But DoD essentially came to us on this. They have a real need for a more prescriptive PFAS method. They really wanted something that had a solid phase extraction and isotope dilution in it. In the end, I know they had a work group that selected an SGS Access SOP, and they came to us and said, if we basically worked with you and had you guys review everything we do, would you consider adopting this as an EPA method as long as we met your requirements? And we were certainly interested for our 1600 series methods. We all reached out to our counterparts at the Office of Land Emergency Management. They were drafting a similar method, and they're interested too. So I see this as a real method harmonization project. If everything goes perfectly, we will hopefully have a method validation that yields an office of water 1600 series method and an SW846 method that are both very similar. I think the main difference potentially between two such methods would be that, obviously our Clean Water Act methods are a bit more prescriptive than the SW846 methods, which are more written as guidances. But I think that there's a real need for both a Clean Water Act and a RCRA method for a variety of PFAS analytes. Right now, the single laboratory validation work is completed. It is a gigantic method validation project. It's looking at wastewater, surface water, groundwater, landfill leachate, soil sediment, biosolid, and fish tissue. So the data load is considerable, and hopefully we'll proceed with writing the report and having something out there this year. But we'll see how it goes. We've been looking at some of the data, and so far I am optimistic. So really, thank you, the Department of Defense, on that one, because they are doing the most of the hard legwork, and they are footing the bill for most of this project. Another project, which I know you guys at SCIL are very interested in. It's been kind of on the back burner for the last few years, but after we updated method 608.3 for pesticides, PCBs, 624.1 for volatile organic compounds, and 625.1 for semi-volatile organic compounds in our last methods update rule, a lot of the lab community said, well, this is helpful because the method reads more like a modern method, but the QC criteria and the MDLs and everything in the method is still from the 1970s multi-lab validation. And we agreed with this observation. And basically, TNI, ACIL, APHL, and WEF all said, well, what if we were able to cobble together a bunch of labs and essentially give you guys a data dump of, updated performance, method performance for these methods. Would you be able to essentially use them and then just maybe not rewrite the method, but just update all of the various QC and detection criteria? And we're very excited at this prospect because we have a lot of old methods in 40 CFR 136, and this would be one of the first times we've really updated a method, including all the QC criteria. And I think that the optics of a project like this are really fantastic because, if it was successful and we went to rulemaking, it would really show that this was a project that, came from the lab community, and that, there was a real desire to update these methods, and that, EPA took the data and did the data crunching, but the real driving force for this came from the laboratory community itself. So we're really hoping this project's successful. I think the study plan is pretty much finalized. The last version we saw looks great. I'm told over 20 labs have volunteered for this project, but at this point, getting all the data together and delivering that is going to be a pretty monumental effort. So we hope TNI, ACIL, APHL, and WEF are pull through for us on this one. We're very curious to see how this project pans out. And it has really interesting implications, not just for this three methods, but if this is successful for other of our older methods that could use some updating. Another project that we're working on that has also been a little bit on the back burner the last year or so is total nitrogen. If you look at our NIPTES regulatory rules for CFR 136, there is no line item for total nitrogen. Now, you can, of course, take total Kjeldahl nitrogen and nitrate and add them together, and you basically have total nitrogen because TKN, takes all of your organic nitrogen and turns it into ammonia, and then nitrate is pretty much all of your inorganic nitrogen. There are a lot of methods out there for total nitrogen. If you had it under one method, I expect the accuracy and precision would be significantly better than adding two methods together. Both ASTM and standard methods have, like ASTM has a high temperature chemofluorescence method, and standard methods has a persulfate digestion, inline method. They both, look promising. Right now, we're really hoping to just sort of, get as much data as we can on the existing methods, seeing if, any of the current data that exists would sort of meet our criteria for multi-lab validation, or at least come close, and see if maybe we might, just be able to create a bit more data for one or two of those methods to get something over the finish line. But this has if you look at our EPA website, nitrogen contamination is considered a very high priority at EPA, and some people even say it's one of the most relevant, contaminants for Clean Water Act purposes. And on top of that, we have, some effluent limitation guidelines coming up, one for meat and poultry, and another one for POTWs that I would say, total nitrogen is highly relevant for both of those industrial categories. We've been working for a while on continuous monitoring. This is really a collaboration project with the Hampton Roads Sanitation District. And I know a lot of other publicly owned treatment works have a lot of interest in this. Some of them are saying, it's a real safety issue, especially if you're in a cold climate, to have someone run out and take a total residual chlorine sample every 15 minutes or half hour, whatever your permit says. Hampton Roads has sunk a lot of investment into online monitors, and if you ever have an opportunity to visit their plants, it's really impressive. They've been working on this a while. It's a heavy lift on the data end, because whenever you have a continuous monitoring instrument that collects a data point every few seconds, and then on top of that you have to filter out all of your QC, like when you calibrate the instrument. Making a data delivery for something like this is very challenging, and I think that's where this project is had some of its speed bumps. But we're still very interested in this. We're really impressed with the work that the Hampton Roads Sanitation District has done. I would say that for some select parameters, it would be really nice for us to have some good sort of rules in place for what is appropriate for a Clean Water Act of regulatory purposes when you're using continuous monitoring. ATP reviews are just a part of our regular work. We essentially accept alternate test procedures. Us at headquarters, we look at the ones that are for nationwide use, and the regions look at ATPs more for regional use or single permits. And sometimes, of course, in those cases, the state looks at them too. We have protocols for EPA review, and for both ATPs and what we often call new method ATPs. They're at the website right there in the middle of the slide if you want to take a look at them. And then, I have to mention, just because it's our newest addition to our website, Lemuel, who runs the ATP national program, he recently reviewed a limited use ATP for dioxins and furans for 1613B using LCMS triple quad. We have an informational webpage about it if you want to go take a look. I would like to clarify that this is something that we consider a positively reviewed ATP. It's not approved yet. You have to go through rulemaking for an ATP to be approved, but it is there for individual permits to potentially use if they get approval from their regulatory authority in their region. And with that, here's my contact information if you want to reach me. And I think, frankly, more relevant is probably slide number 2, which I'll just jump back to, which is our methods team. We're thrilled that we have grown to a 6-person team. When, as Brian said, 4 years ago, we were 2 people. And with that, I'll take any questions. Our method validation is a lot of work, and it's a bit of a grind, but our projects thankfully keep moving forward, and they definitely are moving forward significantly faster with a larger team.
Hey, this is Brian again, real quick. Before we hop to questions, just one quick point of clarification. The total nitrogen method, the 2 activities where it's most readily going to be used are not new ELGs. It's the detailed study of the meat and poultry industry, which we announced initiating last year, and a study of POTWs titled it's a long one. The National Study of Nutrient Removal and Secondary Technologies. We are not announcing new rulemakings here today.
No, it's all right. Thank you for saying that, Brian. And we have websites up for both of those projects. They've been out for a year or two, at least. The POTW and longer.
Okay, thank you, both Brian and Adrian. Questions. One is on the Axis PFAS method. Any timeline or thoughts on what you're going to do about a multi-laboratory validation of the method, assuming that your current data review of the single laboratory validation goes well?
Well, this method's in such a huge rush that I know DoD is already doing some, outreach to laboratories, and we've already written the study plans for the multi-lab validation. So maybe the multi-lab validation will have a few analytes in it that it perhaps shouldn't have, but that's not the end of the world. But this method is sort of on warp speed. I think the main thing that's holding it up is just the huge amount of data that this project generates. Just because it's so many matrices and so many analytes. But with that, I'll probably table the conversation to Jordan's presentation and chime in where appropriate there.
Okay. The other thing I had is, I don't know, you're probably aware of the activities that ACIL has ongoing to try to help establish a COVID-19 and wastewater laboratory accreditation program. Is there any efforts underway in your program there to look at COVID-19 and wastewater methodology, both for surveillance purposes as well as for use like in the beach protection and other protection programs like that? Because I noticed some manufacturers have been coming out with some really quick testing, on-site testing methods, PCR-based testing methods on that.
Well, right now, the COVID method work is mainly in the hands of the Office of Research and Development, and we're sort of looking at what a variety of commercial labs are also doing. We usually, when we jump into method validation, we kind of have we like to have at least an SOP there that's pretty rugged and has been tested a bit. At this point, I think our opinion is that the methods out there probably need to mature a little bit before we jump to method validation, and we need to do a bit more research on available technologies and methodologies. I see actually Tracy Bone is on the call right now, who's our lead microbiologist and is keeping her finger on this hot button way better than I am. If she wants to add to what I said, she's welcome to. Well, that's a good sign. Hopefully what I said I got right then.
I guess not. Does anybody else have questions for the Clean Water Act team? I guess not. I guess you gave an excellent talk. Thank you. And I guess you answered everybody's question.
Yeah,
Thank
you
you, everyone.
actually asked the question I had, David. So,
Okay.
so thank you, Adrian. That was a great update. I appreciate it.
Our pleasure.
Okay. Now we'll move to the AIR program, the Clean Air Act program. Robin Siegel is a senior environmental scientist in the measurement technology group within the Office of Air Quality Planning and Standards. And they're a satellite location, just like Dan is located in Cincinnati. They're located in Research Triangle Park, North Carolina. This is the group that's responsible for the source emissions monitoring methods employed in the Clean Air Act program. As many of you know, for many years now, Robin has been gracious enough to help keep us up to date on the group's activities, and we thank her very much for agreeing to do it this year. So I'll now turn it over to Robin. Bob, you want to switch the screen over to Robin?
So thank you again, David, for inviting me to present today. Wanted to just provide a little background on our group, the Measurement Technology Group in the Office of Air Quality Planning and Standards. We do the measurement methods for the stationary source regulatory program, where we regulate stationary sources of emissions, and these are methods and continuous monitoring specifications that are used to show compliance with the emission standards that are set. The methods typically are short-term methods, and that's where we have the main laboratory interface. The continuous emission monitoring specifications are, for real-time instrumental measurements. So they're totally instrumental. What I'm going to do today is try to focus on the methods that we're working on that might be of interest to the lab community. The first one is we are revising our method for dioxin and furans. That's method 23. We proposed revisions back early last year in January. This method, we use, we collect the gas sample from the stack onto a filter, and in the sampling probe and onto an XAD sorbent. And then the analysis involves an extraction and analysis by high resolution GC, high resolution mass spec. The revisions have focused on making this method, particularly the analytical part, as performance-based as possible. So this will allow for flexibility in method procedures and technology advances. It's isotope dilution for all the target compounds, and having all the additional standards, labeled standards, have made that a great advance, and we're taking advantage of those in this newer method. We've also expanded it for analysis of PCBs and PAHs at the same time, which is a big advance. We received numerous comments on this particular method, and so that slowed us down a bit, and we're expecting to be able to finalize that in the Federal Register late this year. So you can keep an eye out for that, and hopefully some of you commented on it. The next thing that we are working on is a new method for dioxin and furans, as well as the PCBs and PAHs, to take advantage of the triple quad mass spec. And that method, which will be method 31 when it comes out in a proposed form, is now being drafted. And the sampling technique for the gases from the smokestack will be the same as it is in method 23, but of course the analytical will be different. This is being based partially on an approved alternative method under the water program that came from SGS Access, and like method 23, we're aiming to have it be performance-based for flexibility in conducting it, as well as for allowing for advances in technology. And one thing we're doing, we're trying to adopt as much of the Office of Water terminology as possible, so that'll hopefully make it easier for labs to jump right in and use it, and we expect to propose that late this year also. So I just wanted to let you know in general about our program. We have always over the years tried to update our test methods to take advantage of new technologies and to do corrections and such as we go along, and also try to incorporate the modifications that we have approved broadly in our alternative test method program. So we have gotten to the point where we're turning these method update rulemakings around on about a 2-year schedule. Our last one was finalized in October of 2020, and we had revisions to about 26 test methods and monitoring performance specifications. In this particular case, they were mostly corrections and clarifications and some updates, small updates in technology. And we did incorporate a couple of our broadly approved alternative method modifications. One I'll mention in particular was for lead emissions, and we updated the information on how to use alternative analysis procedures, including ICP AES and ICP MS. And we referenced a couple of the SW846 methods. So our next method update should be proposed later this year. Along with everybody else that's spoken so far, we are also working on PFAS. And I think everybody knows there was an EPA action plan issued back in 2019. We now have solid evidence that PFAS is being transported in the air, and so it's in emissions from some of these sources. That was indicated clearly by some downwind soil contamination that's been found by some of the state research that's been done. So we have been working with EPA's Office of Research and Development on PFAS methods for stack emissions. And we have recently posted what we call an other test method. It's a non-regulatory method on our website, and the link is there if you want to take a look at it for doing PFAS from stack emissions. Similar sampling approach to what I just described for the dioxin and furans, except that in addition to the filter and sorbent, we're also analyzing liquid that's captured in the impingers in the sampling chain. Here we're using the LC-MS approach and a multiple reaction monitoring with that, and this is being adapted from the methods 533 and 537.1 that Dan spoke about earlier. And there's about 50 target compounds on the list. And this method has been being used by the Office of Research and Development, as well as a number of states for field studies that they're conducting on PFAS emitters in their state. And they're looking for, of course, how much PFAS is in the emissions, and they're looking at destruction and control efficiencies for controls for these emissions, so that we can figure out if we ever have the opportunity to regulate this, how we would set up a standard. As far as that other test method 45, we are looking for feedback on that. So if any of you take advantage of using that, we would love to hear about your experiences with it, because we'd like to improve it if there's ways that we can do that. And we're also interested, I think as Adrian was talking about, in having a overall method for the thousands of PFAS compounds that are out there, something more generic. And I will be sure to pass on the ASTM work that's being done to the folks in my group that are working on PFAS. I appreciate that. I learned something new today. And to mention of our alternative test method approval process, we have a relatively nimble process because we can do it without rulemaking. We can do it, there's already been rulemaking done to allow us to do these official letters to do these approvals. We typically act on about 50 requests per year. Most approvals are facility specific, but we do on the order of 2 to 5 broadly applicable kind of national approvals a year, and those are posted on our website at the link there in the slide. And we also publish those in the Federal Register once a year. And just a mention of something that might be of interest, in 2020, we approved the use of HPLC in lieu of a GC for analysis of organic acids under our EPA method 18, which is for organic compounds. So with that, I will open it up to questions.
Robin, David, I have one quick question. On your method 45, are you finding much breakthrough from the sorbents into the impinger on during the analysis of the PFAS compounds?
That is a good question, and that is not one I can answer because I have not been the person doing that work myself, but Raymond Merrill is the person who's tied into that from our group, and I'm sure he could answer that. So if you want to
tell Ray I
send,
said hi, and I'll give him a call.
I figured you probably knew him, yes.
Is anybody, thank you very much, Robin. Does anybody else have any questions for Robin on the AIR program? I guess not. I said thank you very much.
You are totally welcome.
Okay, joining us today from the Office of Resource Conservation and Recovery, you just heard Troy Strock from their SW846 program, is Troy and also Kim Kirkland, who's the chief of the waste characterization branch within the office. And as probably you all know, they're the group that's responsible for the SW846 program. As I mentioned, Kim is the chief of the branch, and Troy Strock, who's a senior chemist and the organic methods lead in the group. And Kristen Gagne is a postdoctoral fellow in the program. Many of you may have remembered Christina Langua Miller. She was with the program until fairly recently when she moved over to EPA's Emergency Laboratory Response Network program. And I expect she'll be joining us on our call next year if she hasn't joined us today. And will be hopefully bring us up to speed on that program. So let me now turn it over to Kim and Troy and Kristen.
So I have a few slides I'm going to present, and I'm going to turn it over to Kristen and let her talk about 3050C, and then I'll come back. But I just want to say I'm honored to be part of this, to be speaking to you guys today. You know, I think it's it's very interesting to talk about all these different applications, all these different needs, regulatory and some risk-based needs for data, and these test methods are really providing EPA stakeholders the information basis to make decisions about to keep people safe. And they're generally speaking, the methods are not they're not as ambiguous or subject to interpretation maybe as other parts of that process of risk management. And so I really like the sort of the hard science aspect of this. And so I just wanted to say not too many asides, but I just wanted to say I'm glad to be here. So I've been here. I just passed a year in this position, working in ORCR, and the SW846. It's published by the Office of Resource Conservation and Recovery. I think the first edition was published in 1980. I'm not sure if David was with the agency then, or if, but maybe shortly after was involved with this program. And so it's a collection of more than 200 test methods. Some of them are required by RCRA, and the non-required methods are guidance, and can be modified under certain conditions. They're used by ORCR for RCRA. They're also used by other programs in the Office of Land and Environmental Management, like Superfund. They're used for waste characterization, for site characterization and cleanup. Some of these methods are dated. Some of them were last published in 1986, and so we have our job is to try to keep this compendium of methods current and relevant for EPA, for the government, and for the regulated community, and so we can sort of come to some common interpretation of is this a risk? Is this a unacceptable risk or not? So I'm just going to talk a bit about our current projects, which is the 3050C, the acid digestion of sediment, soil, sludges, and soils. So C is the update, 3050B is a currently published version. And then the 3512 and 8327 that were validated for PFAS in non-potable waters. And so it's a direct inject, solvent solution, direct inject method. And then I'm going to talk a little briefly about the leaf methods that are these leach testing methods that ORD is working on development of, and is something that's hopefully forthcoming, and then some of our other near future plans. So, this is where I get to turn it over to Kristen. Okay. Kristen.
Good afternoon, everyone. I'm going to give you a brief update about 3050C. Some things I wanted to point out is the main updates between 3050B and 3050C include the combining of a two-step digestion into a one-step digestion for all determinative instruments. 3050C uses the addition of nitric acid and hydrochloric acid together with the additional addition of concentrated hydrochloric acid at the end of the method, unlike 3050B, which was just nitric acid digestion. The reasoning behind these changes was due to the modernization of ICP-MS, allowing for the correction of chloride-related interferences and allowing the addition of hydrochloric acid to the digestion method increases the solubility of silver and antimony. Our validation study concluded at the end of 2019 and involved 10 laboratories running either ICP-MS or ICP-OES or both. Each lab digested 5 reference materials in triplicate using both digestion methods in order to compare the two. The reference materials included sediment, soils, and sludges. We are currently working on compiling the statistics report and the quality control summary. And our next steps, once that's complete, is to create a work group and publish the method for public comment. Next slide, Troy. So I just wanted to present some preliminary results. This slide is showcasing a positively affected analyte of antimony. So for example, the top two graphs are showing a 1-to-1 ratio line in black. Anything below the line had increased solubility in 3050C compared to 3050B due to the addition of hydrochloric acid. And because we saw this increase in solubility in 3050C, we wanted to see if it was statistically significant. So we utilized the Bland-Altman plots, which are the lower two plots, that allow for the statistical comparison of two methods. The two bottom plots have the average of the two methods on the x-axis and the difference between the two methods on the y-axis. The dotted lines that you see on these graphs showcase the positive and negative 95% confidence interval. And based on the Bland-Altman graph, anything outside of those 95% confidence intervals showcases a statistically difference between the two methods. As I have circled in orange, antimony showcased a 19% and a 27% of those outside samples, indicating that the method 3050B and 3050C are statistically different. As anything above 10% is considered statistically different. So we have 19% and 27% for ICP-MS and ICP-OES. Next slide, please, Troy. The majority of the analytes were not affected. One of the examples I have here is lead. You can see the majority of the samples lie on the 1-to-1 ratio line in the upper two graphs, and that less than 4% of the samples lie outside of the confidence intervals on the Bland-Altman test. So that tells us that 3050C is not statistically different from 3050B and vice versa. So they are equivalent to each other. The non-affected analytes, which I provided an example here, represent 63% of the analytes for ICP-OES and then 87% of the analytes for ICP-MS. Next slide, please. All other analytes showed a limited effect. So you can see here we have aluminum as an example, and some of the points showcase better solubility in 3050B and better solubility in 3050C. So again, we did the Bland-Altman to compare these two methods and saw that While there are differences in the two methods, they're not statistically different, as the total samples outside of 95% confidence interval is less than 10%. The only analyte that was statistically different was antimony that I showed on the second slide of this presentation. And with that, I'll give it back to Troy.
Okay, I realized I have failed you guys, and I didn't really properly introduce Kristen. I mean, I know Dave had mentioned her, but she's working as she's an ORISE postdoc in ORCR, and she's been there since August of 2020, and she sort of took this project over from Christy after Christy moved to OEM, and she's been working with Katie Adams in Region 10 on this, the sort of data evaluation and so on, and our plan is to put our summaries reports, the statistics report, and the data QC summary report together with the proposed method and post it for public comment. Kim said we don't have a project lead, and speaking of staffing, we are short-staffed especially since Christy left. I think we are the smallest of the methods programs here, but we are interviewing for a new position for the inorganic chemist position, and hopefully we can get some more FTEs past that. But first thing first. So is anybody? I suppose I could ask if anybody has any questions about that. And so I could transition to the topic of the day, PFAS. So we are really in the final stages of I would say finalizing these methods, 3512 and 8327. And so this is just one-to-one solvent dilution of non-potable waters. The samples get vortex to mix them. They get filtered through a particle filter. They add a little bit of acetic acid, and then they get analyzed. No dig on the drinking water program, but this is really going to be a low amount of effort for sample prep, I think. And so the Lord knows the data analysis is still complicated, but the amount of labor that it takes for a lab to process these samples is going to be very limited. And so I think there's advantage. And so method to do it this way, method 8327 is the determinative method. So SW846, we try to modularize these methods with separate preparation, cleanup, and determinative methods. And so the determinative method is just for the LC-MS, MS analysis, and like as mentioned before, it's very specific, it's very sensitive, and for the validation study, labs were calibrating the range down to 5 nanograms per liter in standards, and the lowest LLOQ, so that's our lower limit of quantitation, that was evaluated in the study was 10 nanograms per liter, and I think it's fair to say that most labs were able to verify, through a spiked, sample prepared through all this preparation steps and analyzed on the instrument, that they could meet lower limits of quantitation in 10 to 20 nanograms per liter range without a lot of practice using this method. And so it was reasonably successful, I think, in that respect. The method was validated as the external standard calibration method, which is how it was proposed to ORCR. And so that was one thing that was, I would say, contentious about it. I'll say this is some advantages and disadvantages. You definitely need a modern LC-MS to achieve the sensitivity needed for the method and so on. But I think this is really a way of the future for a lot of water analysis, is just be able to do direct analysis with minimal prep. So this is a good example of that. So regarding the public comments that we got, I just wanted to touch on them briefly. The most common comment that we got was use isotope dilution. And I think there's a lot of good reasons to do that. Here we validated this method for 24 target analytes, and we used 19 isotopically labeled analogs of these target analytes as surrogates. But it wasn't the way that the validation study was conducted. And so we could you know, we could go back and reprocess the data, and we could you know, use this a sort of a pseudo isotope dilution approach, because the calibration standards all had the labeled compounds calibrated multi-point instead of at a single concentration. It's really the only difference between isotope dilution and the way the study was conducted. But I would say that since the way that the validation study was conducted was by external standard, that's sort of the way that we're thinking to finish finalize the method. I think we'll end up with a FAQ, a frequently asked question on our website that says, is isotope dilution allowed? And we're going to say it's acceptable modification as long as it's acceptable with your end data user and you can show that it works. And so I think that's going to be probably the best we can do in the near term. And so some of the other comments that we got about the method were, you know, the people wanted, you know, the solid phase extraction, the solvent extraction for solids. They wanted the isotope dilution calibration. These are sort of the themes that we saw. They wanted to see additional analytes included, and all of these things I think are DoD is working on and has planned to complete validation studies for, you know, that will include all of these components. So that's so for the first step, I think it's an important first step. So let's see, I go next. So this is something I wanted to bring to your group's attention. You know, was you know, the Region 5 lab was a method developer for 8327, and recently they've have observed some background contamination of PFAS in laboratory supplies. You know, you know, this method is calibrating these compounds to very low levels, so you know, low parts per trillion levels, and they're seeing, you know, sometimes low and sometimes variable background contamination in their supplies, such as polypropylene tubes, 15 and 50 ml tubes, glass autosampler vials, and maybe polypropylene autosampler vials. I'm not sure about that, but I haven't seen a lot of data, but I was told that, you know, what they were seeing was, you know, C6 to C12 perfluorocarboxylic acids, and you know, some non-target analytes for method 8327, but that might be of interest to people, to EPA, and so I wanted to ask the question whether or not this is something that ASIL members have seen in their laboratories, and I can save that. I can save that for the end. But if you guys have some ideas of you know, whether you guys have seen this problem and how you might have resolved it, I'd be interested to know more. So another project that's ongoing right now at EPA, and this is being led by Office of Research and Development by Susan Thornlow. They're working on these leach testing methods that are, I would say, like parameter-based leach testing methods that are designed to evaluate, you know, leaching behavior under different environmental conditions, you know, to basically provide some lab-based simulations of leaching behavior for different exposure scenarios, for different treatments, for stabilization, solidification, and so on. So the methods really are 1313, which is a, you know, batch leaching test. So it's just a solid aqueous equilibration at different pHs to see the effect of pH on leaching. The 1314 is a column leaching test. They're putting you know, a solid sample of soil in a column and pushing pushing leaching fluid through it, and then collecting fractions and looking at the you know, the kinetics of the leaching, and then the method 1315 is really a leaching test that's designed for, they call it monolithic or compacted granular materials. So it's something you could test. Well, if we put this material in concrete, for example, will these chemicals leach out of it over time? and it's a sort of they call it semi-dynamic leaching test. They basically, put it in this tank and mix the water around, and then periodically change water. And then method 1316 is really just leaching as a function of liquid to solid ratio. And so here are these different, these different parameters that these EPA is sort of trying to evaluate in terms of trying to better understand or get a handle on leaching behavior that's a little bit broader than you might get out of TCLP, which is designed to simulate this like municipal solid waste landfill, or SPOP, which is sort of designed to simulate this rain infiltration. And so that's the sort of the background for that. The methods were initially validated and published for metals, and they're what they're working on is adapting them for organics. And some of the issues they have to come to terms with to adapt them for organics are compatibility with apparatus, separating liquids and solids, which can go hand in hand with the formation of colloids, and how do you deal with those, because those can control leaching behavior for organics. And then controlling volatile loss, we have to worry about volatile organics and leaching behavior of those two. All these topics have come up before, and I think I think this approach is really more for sort of to better engineer remediation technologies, to better evaluate them before they get deployed in the field and so on. So I'll move on. Okay, so SW 846 methods program, here just a sort of snapshot of what, some of the things that we have, planned for the near future. One of the things that we've been working on is revamping the frequently asked questions on the SW 846 website. I think we have a beta version of a website that looks pretty good that haven't made available to the public yet, but it should come out soon. And maybe it's a couple months away, I'm not sure. When it comes to the PFAS and solids, obviously very, very a high interest to the analytical community. And I know the DoD is working on an approach to PFAS and solids. I know there's some ORD methods for prep and cleanup for PFAS that might be interesting too. But we don't have any concrete plans to work on that project yet. We're talking about planning still. And so when it comes to the other updates we're looking at for SW 846, we're talking about incorporating the waste sampling draft technical guidance into Chapter 9. We have a couple of sampling methods that are, one of them, this passive sampling of pHs and PCBs and sediment, is a CERTA project that OSREADY and DoD are working on. And I think they're not sure. I think they're close to the end of the project, and so we're hoping that they'll provide data that's supportive of publication of a passive sampling method. We have a couple of, an appendix in 8330B that's for a representative sampling of energetics in soils, that we're considering making a multi-incremental sampling method, and we have a metals in soils appendix to 3050C that was written in collaboration with DoD too, that we're considering making into a standalone method as well. And then we have a whole host of other things. We we have a set of validated methods on the SW 846 website. I think there's 17 of them that we'd like to clean up. They're some of these methods, 5035A is widely used, but it was never put through public comment. And so we have the opportunity, I think, in the near term to try to get that method through that public comment and finalize it. We also have a lot of proposals, and that external organizations are, they're either planning or conducting method validation studies, including the, explosives by HPLC UV from DoD. They're proposed to include additional analytes and allow LCM SMS for determination. There's the isotope dilution method for PFAS. I'm sure you've heard enough already about, and you'll hear about more probably from DoD. And then we have we had a proposal for graphitized carbon cleanup for pesticides extracts. We have a method that's been validated for arsenic species in fish tissue to include arsenic in lead in vitro bioavailability assay, which is 1340. There's more. And so I just wanted to say we have a lot in the queue, and so some of that is really people power limited, and we're hoping to address that limitation as soon as we can. So here are the methods team contacts. Kim Kirkland's the branch chief, and then me. Feel free to reach out to me if you have any questions or would like to propose actually, if you need us to address any problems or concerns you have with SW846 methods, I would be glad to hear them. So, and thanks to Kristen for presenting some information about the 3050C study. All right, I can leave you with that.
Okay. Anybody have questions for Troy or Kristen or Kim? I don't know.
Yeah, Dave, this is Jordan. So a couple things really quick, Troy. The first is, so we were made aware of that issue with PFAS contamination that you guys saw, and we actually did some outreach to our laboratories that are accredited for PFAS by Table B15 to our QSM, and we got about 14 respondents from the DoD ELAP labs, and several labs saw some contamination. Some of them blamed it on change in supplies due to shortages because of COVID. But I would say only about 50% of them saw an issue. All of our labs obviously test all their supplies by batch when they're arrived. But so it is something that they've seen. They did see a change from suppliers, like I said, for different things coming forward. So we did see some evidence of that as well. But the concentrations they were seeing in their supplies was quite low. So we were not greatly concerned about what they reported back.
Okay, I know that a lot of if you're doing the solid phase extraction, you got the big concentration step, and you don't necessarily have to calibrate down to as low of a concentration on the instrument to be able to get to the that low per trillion concentrations for the limits of quantitation. So so it may be somehow or another related to the specific analysis where the calibration range is really low.
Troy, that would make a lot of sense, Troy, and that would carry it forward. One other question I have for you though was you did mention the update to, or at least something involving the 8030B appendix. And can you provide with some information? What are you guys looking to do with that appendix for 8330B?
Oh, we were just actually, what we had talked about doing was making it a standalone method, a sample collection method. And so I'd be glad to talk to you more about it, because I know that it was written, sort of for DoD's purposes.
Yeah.
I don't. Chuck Ramsey was involved in it, and maybe Alan Hewitt and Tom Jenkins. And so I would love to talk to you more about it, because I think that you guys could really help make it the best thing it could be. And so that's something we could follow up about if you have some specific suggestions.
Absolutely, Troy. We would love to talk to you about that and provide some feedback and some support if you guys would take it. So we're happy to be involved.
Okay.
Troy, this is William.
Yes,
regarding the contamination. So of course, as you mentioned, it's being found by Larry at Region 5. But we being Larry at ASTM, we're validating a new method with the intent to put about 40 or so parameters in it. And the process, would be evaluate all the containers. And so we're doing more than one or two blanks. This is 10, 20, 30 blanks all in a row. And so the contamination isn't necessarily I pick up a vial out of the box and I get it in that one. It's I pick up 10 vials out of the box and I get it in one or two. So it's a very sporadic contamination, which is actually even worse, because I might run a blank and I get blank. I run my LCS, I get okay, and then I run some samples, they have hits, I report them.
Right. So, I mean, it's not just it's not just, you know, the concentration, but also variability. It's a very important part of it.
And one of the compounds we're just going to have to kick out. I don't know how to name it, but it's in everything. And so that one's just going to have to get kicked out of the method.
Okay.
I don't know if it has any bearing on this, but I was recently read an article that says there's a fair amount of plastics that are treated with these PFAS chemicals as, I guess, barrier coatings to help them be more resistant to permeation. And I don't know how much that's contributing to this problem, that it's getting to be ubiquitous.
Yeah, it's the thing is that Larry had said, and I don't mean to just, this is something I haven't looked at directly, so I'm speaking in the sort of a third-hand knowledge or a second-hand knowledge, but what he had said was that these supplies previously were reliable for them, and he said maybe these things are coming to multiple different manufacturers from some common sources and not necessarily being produced by everybody. And so but he had seen some changes in this performance of a material that was previously reliable. And so it's just something to keep an eye out for. And and maybe there's a way that the ways that we could address them, and if the decision the issue for drinking water, for the type of sample containers that they're using, it may be specific to a certain type of material like polypropylene versus polyethylene and so on. So it's I think there's more to learn about it, but I do appreciate your all's feedback about it. If you got anything, if you have any more information you can provide, you want to send me a message afterward, I would be glad to have it.
Thank you. Any other questions, comments for the record team? Well, thank you again. And we'll now turn to Jordan, who's been commenting here. And Jordan is the director of the Navy Laboratory Quality and Accreditation Office. And he also chairs the Department of Defense-wide Environmental Data Quality Work Group. The work group develops the standards for the DoD-wide environmental restoration monitoring efforts and also oversees the data quality assurance program. I understand the program is also used by the Department of Energy's restoration program, environmental restoration program. The work they do is well known to our industry as a result of the tremendous amount of monitoring done by DoD and DOE, and also the influence that the quality assurance standards and laboratory accreditation standards that his program has put in place on laboratory quality systems that are generally used in the environmental field. So thank you, Jordan. Let me turn it over to him. And
thank you, David. I appreciate the invitation to come speak with you guys today and sort of talk through. Obviously, so I want to thank David and you guys for inviting me to come speak with you and to talk a little bit about the EDQW. So I'll give a little brief overview. David gave a really good job of a good summation of what we do and what we're focused on. Many of you guys are familiar with the program and familiar with me. Then I'll talk a little bit about our DoD ELAP program, which Dave mentioned as well, and then talk a little bit about updates to that we're working on to the DoD QSM. I don't have a whole lot of slides about the PFAS updated method, but I'd be happy to answer any questions that I can sort of about those efforts and how we're working closely with Adrian and his folks to kind of get that out the door and sort of the importance for us, as I'm sure you guys are aware. When Dan was talking earlier about not having a day without PFAS, I can completely relate to that, as I'm sure many of you can as well. So the EDQW, like Dave said, the main focus of the EDQW really is to ensure that that the data we're using for our decisions is of the appropriate quality, and we do so through sort of what's listed here in these bullets, right? We develop and recommend policy related to sampling, testing, and quality assurance for environmental programs to eliminate redundancy, streamline programs, and improve data quality and promote data integrity. The EDQW is made up of representatives from the Air Force and the Army and the Navy, each one providing a principal. So I'm the Navy principal, I'm the chair. We've got the Army principal, who's Brian Jordan, and the Air Force principal, who's Seb Gillette. And we coordinate the exchange of information among the DoD components, sort of across the board, to kind of get us to sort of march to the beat of the same drummer. And we develop issuances and implement environmental quality systems, promote cost-effective government oversight, and obviously implement the DoD ELAB program. So this is sort of how we function and report. You know, we've got subgroups. We've got a subgroup that's in charge of actually updating the QSM. We've got one in charge of data review and management that's developing our data validation guidelines that we're working on these days. You know, we've got one that focuses on emerging contaminants that goes forward. And so we've got these subgroups and subcommittees. They report up to the principals, right? I report up to the Deputy Assistant Secretary of Defense for Environment, Energy, and Resilience. Although that there's a little bit of flux in leadership as things changed towards the end of the previous administration, and they look like they might be changing going forward. But essentially, that's how we report up the chain. And we obviously interface externally with the IDQTF, which is essentially us, DOE, and the folks at FIFRO at EPA, and TNI as well. So the DoD ELAB program. So, you know, in 1996, there was a couple of IG reports that came out that really highlighted the problems that existed in the collection of data in support of the CERCLA program, really for the federal agencies. Because unlike, you know, that was mentioned earlier by Dan and the Safe Drinking Water Act, you know, those programs have, you know, laboratory certification requirements associated with them that are fairly stringent. But the same thing isn't true for the restoration side of the house. And so, you know, we the DoD, weren't doing a great job of oversight over our laboratories and the testing process. And so that coincided with roughly around the same time of the creation of the EDQW. The EDQW predated those IG reports by only a couple of months. So they took on this mission to sort of address some of the lab testing consistencies in 1996. And it took a number of years. I think it was the year 2000, when the first QSM was put out. That's really what the first step was for us to come up with a consolidated standard that we use for lab assessments. And then we went on with each component having their own program to assess laboratories and approve them for use. But those programs were, they had issues associated with, maybe the best way to say it. They really weren't open and fair. They relied on prime contractors nominating laboratories to get into the process, which really created its own sort of issue. So in 2009, we actually created the DoD ELAB program, where we use third-party accrediting bodies to go out and assess laboratories to the requirements of the QSM. It's been a tremendous success for us carrying forward. And I have to say, and I don't know if I say this enough, but you know, we set up this program with a significant amount of assistance from the folks at NIST. So NIST has, as part of their core mission, the implementation by the government, both federal and state governments, of consensus standards. And so NIST came and really helped us establish this program. They gave us a lot of information. They gave us some tools to sort of start with and some sort of foundational things to carry us forward. And so, like I said, it's been a terrific program. Many of you guys are associated with it or familiar with it, and it really has allowed us to stop spending, you know, our time focusing, at least the, you know, DoD resource specifically focusing on lab requirements and really focusing on project-specific requirements is really where the focus should be. So we've got 3 U.S.-based accrediting bodies. They all assign conditions and criteria to sort of have that designation, right? And so we've got 3 of them. We started off with 4. 2 of them merged, right? So A-class and LAB became ANAB. Is sort of how that fits. And so that's sort of how things are broken up across the ABs for our program. And you can see here, this shows you essentially right now we've got 78 labs in the program. And there's a downward trend in the number of labs supporting our program. Really, the peak was in 2012. And some of this is due to consolidation in the industry, as you guys probably know better than I do. And some of this is actually, you know, due to the, you know, some people don't find it economically beneficial, right, to be part of the program. We do not have a shortage of laboratories. We can meet all of our testing requirements. And I've been asked that question, you know, a couple of times, specific with PFAS, right? Especially as, you know, testing was ramping up. There were a number of states that wanted to require laboratories to test to our requirements, but we're worried about overtaxing our laboratories. And my response to them was, don't worry about it, because you know, you send them more samples and they will expand to meet the need, which has clearly happened in provided place. But it is an interesting thing, and something we do track is obviously the number of labs in the program. You know, the basis of the accreditation is our quality systems manual, the DoD QSM, DoD DOE QSM. So we combined this document with the folks at DOE a number of years ago, and in 2018, actually, they adopted the same assessment program that we did for laboratories. So they used the same 3 accreditation bodies to perform assessments for us. And I look at this as a tremendous success. So it actually mirrored what the services did. So the services had different requirements documents. We got everyone to come together. We came up with one document, and then after a number of years, we were able to actually put together a program that we all utilize. Well, it happened much quicker with DOE, but DOE consolidated and used the same quality systems manual that we used for a number of years, and then we were able to get them to sort of expand and utilize the same accreditation program. And this is obviously something that I think is a really good idea, and I'm hoping that ACIL agrees. I mean, there is no reason for repetitive assessment, right? So if we can all sort of stack hands on standard requirements, and then it should make your lives as laboratories easier. It really, it lifts up this burden, but we're ensuring everyone's meeting the baseline requirements, which I think is very, very helpful. So obviously, we use ISO 17025 as the basis, as well as P&I. And like I said, the folks at DOE use it for their CAP program. Right now, we're at version 5.3 of the QSM. It was released in 2019, and I charged the subgroup who updated that document to get that done in a year, which was maybe a little unreasonable, but they met the goal, so maybe it wasn't unreasonable, but they were certainly stressed about it. And that was because we were sort of chasing implementing the 2017 requirements. We wanted the document to be compliant with ISO 17025 2017. And so the only real significant changes, other than some changes to some of the B15 requirements, the specific method requirements, was the update to ensure that we were compliant with the 2017 standards. So as many of you know, hopefully, the 2017 standard in most cases actually relaxed requirements versus the previous ISO standards. And so that was pretty easy for us to do relatively, but we had to look through the whole document to ensure that was the process. And so we had a 2-year implementation plan, and at this point, all of our labs are accredited to the 5.3 version of the QSM. So right now, we're looking at updating to version 6. And here's where I gave the subgroup more time. I said, you guys race to get the 5.3 version out. You have as much time as you wanted for the 6 version. They were hoping to have that actually done much sooner. Now it looks like January 2022 is the date that they've sort of come up with. But as I'm sure many of you are aware, and many of you have been affected, right? The inability to travel due to COVID really had an impact. I mean, the subgroup was meeting on a regular basis, face-to-face, and able to sort of hammer out a lot of technical issues. That got slowed down, and really we lost some momentum sort of based on that. And so they picked up speed again and really worked out a really good system for having their meetings that are really carrying that forward. And so, like I said, the anticipated release that is 2022. So currently, the QSM version 6 is under revision to align with 17025. So the structure of the document is going to align to 17025. And it's going to be compliant with P&I 2016. And I'm assuming, once again, you guys are familiar with this, but 17025 2017 transitioned to a risk-based approach for many requirements. And some members of the EDQW are a little bit concerned about the paradigm shift. And what impact it's going to have by allowing sort of or increasing the sort of risk control that the laboratories have. And so that's under discussion. I don't think it's going to have a huge impact, but like I said, there is some of that concern. And there's some discussion about that amongst the subgroup and the EDQW in general. We're also looking at a couple of major things. The first would be our LOD, LOQ scheme is being evaluated. So, what we have in there for detection and quantitation, I charged the subgroup with obviously studying what's out there, what the EPA is currently has in place, because it's been a long time since we've updated our detection and quantitation scheme. And I don't want to make it overly burdensome. If we can have similar definitions for LOD and LOQ that for other quality control standards that already exist, then I think that would make your lives as laboratories easier and our lives as implementing it easier. Because now we're not chasing you for something just specific for us. And so that's sort of, they're looking into that. I'm not going to guarantee significant change, but I'm telling you it is something that they are looking at, and that's what they were charged with doing. So Appendix A of the QSM, which many of you might not even be familiar with, it has some reporting requirements in there, but it's not even requirements. It's like suggestions, and it's not used a significant amount. And so there's some, it's being sort of evaluated if it's going to be included, and if it is, what stuff will be sort of in there. But the biggest effort really is that all the Appendix B tables are being evaluated against the most current EPA methods. So that's going through that process right now. It should be. I'll note this again, but Table B23 in the document is about the use of incremental sampling methodology, and so that's going to be removed from this version of it. We're looking at some specific tables based on some work that we're conducting with potential support from CertaP and CCP, some research specifically for PAHs in soil. If you looked at Table B23, it really mostly references what would be in your QAP. We are looking at putting out some guidance documents, essentially to talk about how ISM should be sort of released and how it should be utilized and what the project team should be considering when they're going through that process if it hasn't gone through a validation process, the ISM preparing of samples. So we've got some new tables coming out. We've got a new LCM SMS for chemical agent breakdown products. There's going to be an 8260 and 8270 SIM table. This potential ISM table is what I referred to, referencing back to the, you heard Troy's group talk a little bit about the metals. So referencing back to some of that work that was done for metals preparation, as well as, like I said, the stuff working on for PAH. The 1668 PCB configures is going to be there, and Table B15 to potentially be revised to be consistent with the EPA method development efforts on PFAS. So, so this is so I know you're all going to be really excited about the fact that this is my only callback for the PFAS testing. But as was mentioned sort of throughout the sessions today, we are working very closely with Adrian's group, as well as with funding from CertaP and ESTCP to put together a 1600 series method for PFAS that essentially is compliant with the requirements of Table B15, the QC requirements that are there that sort of meet that need. And I can tell you that while and many of you have probably heard me say this before, while I applaud our efforts in putting B15 together, I really don't like that way of doing business. I really, I would say that myself and the rest of EDQW is pretty uncomfortable with the fact that we sort of had to put that together because of the fact of when these emerging contaminants come out and there aren't methods for them, it makes life quite challenging for us. And so having an EPA method and having us have some criteria associated with it is a much more comfortable place for us to live. And I am quite excited about the fact that we're making progress towards that effort. So this is where we are currently with the QSM. Module 1, Module 3, and Module 7 have all been sent out for comment. We've got those comments back. They've been collated, and the subgroup is going through them now. We're about to get Module 4, which is general chemistry, and Module 8, which is some quality systems for industrial hygiene testing, which is the DoD only. Those are about to go out. They should be going out before the end of this month. And then we typically give a month time frame for sort of feedback and comment from the community. Obviously we've got general chemistry is going to be a pretty big deal for us to get out and sort of complete. So that's being worked on as we speak, as well as the radiochemistry piece. And so that wraps up sort of what I wanted to cover today. And like I said, I'm happy to answer and address any question I can about our PFAS efforts and sort of where things sit. Adrian indicated the fact that the single lab validation study is complete, and that is true. We have the data now. But he also indicated correctly the fact that it is a lot of data. And so handling and going through that process is taking some time. And so that's sort of where that progress is at this point. So with that, David, I'll open it up to questions.
Anyone have questions for Jordan?
I do. Jordan, in table B15 for PFAS in the revision to 6.0, the difference between EPA methods and DoD QSM, I see there's the use of carbon material. Will that ever change in the revision?
Oh, you're talking about the EnviroCarb, the cleanup step?
Yeah.
Right. So that's a good question. There's been a debate, within the EDQW about that cleanup step, and sort of its value and its benefit. And so we have seen with certain matrices, I believe specifically tissue matrices, that it's a absolutely necessary step to sort of assist with interferences. So we haven't seen